Do you guys have a note for, okay, that's good. Do you guys have the note for 5.2? Now we go to 5.2. Okay, so 5.2, we're going to talk about area. That's how we say that this Riemann sum, okay, we take this sample point in each subinterval and we sum up those m rectangle, and then we take the limit as n go to infinity, that will approach to the exact area under the curve, right? So we define the area under the curve over here, okay? We define this area to be the limit of this Riemann sum. And we define the limit of this Riemann sum over here. By definition, we define this limit of this Riemann sum as the integral of this function. So this integral here is the limit of this Riemann sum over here. Now the delta x over here, we're going to replace that by dx. And each one of this is f xi star, and then we replace this xi star here by just x. Okay, this x over here. The limit of this Riemann sum, we define that to be this integral. It's the integral of f of x, okay, where dx over here go from a to b. So the function starts from here and end here. This a here is called the lower limit of this integral. The b here is the upper limit of this integral. So if you try to visualize this integral, you can try to picture that as this area under the curve. Okay, you can try it that way. So this is the integral sign. It's the limit of this Riemann sum. Okay, so the integral is the limit of this Riemann sum. Do you know who's our author for our textbook, our calculus textbook? It's a Stowe. Okay, he has a mention, and in his mention, the wall is in this shape, in this integral sign. Okay, now he makes so much money. Okay, out of all the textbook, math textbook they wrote, he has a mention is over $10 million. Okay, he passed away a couple years ago, but it was interesting that to see that mention that all the wall built in the shape of the integral sign. Okay, you can Google that and look it up. Okay, so this one over here is a definite integral. It's called a definite integral because the upper and lower limit are specified. Okay, it's the definite integral of this function f from a to b. Okay, that's how you say it. Okay, now let's try to practice on this. So I have the limit of this Riemann sum over here. Let's express this as an integral on 0 to pi. Okay, so I put the integral sign here. So the limit of this Riemann sum defined to be an integral, and the delta x are replaced by dx. What do we do with the xi over here? Replaced by what? The xi here is being replaced by what? What did you do over here? Just replace by x. Okay, so just put it instead of xi, we put x over here. So will be the function x cubed plus x times sine of x. And then delta x here replaced by dx. X here go from 0 to pi. This is the lower limit, that's the upper limit. Okay, so 0 to pi. So the limit of this Riemann sum is this integral over here. Think about it as the net area under this curve, x cubed plus x times sine x. Okay. Okay, the second one. We're given this function over here. Okay. I found that I factor this into this. So what are the x-intercept over here?
0.
Yes, you got it. As one of them is 0, right? And then the other one, x squared minus 6 equals 0, x squared equals 6. So x equal to
plus or minus square root of 6.
Square root of 6, right? Yes, you got it. So plus or minus square root of 6. So we have 3 x-intercept right here. Okay, the graph of it look like this. Okay, S shape. Okay, because of cube. Okay, those are the 3 x-intercept. Okay, you see over here, this area here is this graph. The graph over here is above this x-axis. So if you use Riemann sum, so you get a positive result, right? Okay, and then what happened over here is the next one over here. Okay, So this one over here, the graph is below the curve. So the y coordinate for all those endpoints will be negative. So the v minus 1 will be negative. So the integral correspond to this part here will be negative. So the net area under this curve on 0 to 3 right here, you have this area, you have A1 plus A2, where A1 here will be negative, okay? A2 will be positive, okay? Above the x-axis is positive. Below that, it will be negative, okay? So this integral is the sum of these two, okay? Question? The next one over here. This is an integral over here. Let's evaluate this integral by thinking of it in terms of that area. So you might be able, you might be asked to do something like this in the final, okay? To evaluate the integral by thinking of this in terms of that area. Okay? So first of all, this function, this is the function that we integrate with, okay? So this is f of x. So f of x equal to this, which means the same as y equal to this. So y equal to the square root, positive square root of 1 minus x squared. So what's the graph of this equation? So we're going to square both sides. So square both sides right here. You get y squared equal to 1 minus x squared. Now let's bring the x squared and y squared together. So we have x squared plus y squared equal to 1, which is an unit circle center at, what's the center of this unit circle? What's the center of that circle?
0? No.
Yeah, 0, 0, right? So 0, 0 is the center. And what's the radius?
1.
1. Yeah, the radius is 1. So I draw the circle over here, center at the origin with radius 1. Now, this y equal to positive square root, right? It's positive square root of this. So y is going to be non-negative. So that will correspond to this upper half of the circle. Y cannot be negative. This is a positive root. So this corresponds to the upper half of this circle. Now this integral over here corresponds to this area under the curve, area under this pink curve right here. X go from 0 to 1. So x start from 0 and then 1. Then the area under the curve is this green highlighted area, right? Okay. So we can find this integral by interpreting this as this area. So what's the area of this? Well, what's the area for the whole circle? Area of the whole unit circle is pi r squared. The r here it is 1, right? So the radius is 1. So the area for this unit circle is pi. It's going to be pi. So the area for this unit circle, are you guys able to see my? Okay, let me see if I can see this. Yeah, you guys see it, okay? Good. Okay. So the area for this unit circle over here, it is pi. So this is 1/4 of this unit circle. So it's 1/4 times that. So it's pi over 4. So this is pi over 4. Now notice that x go from 0 to 1. Okay, so the area here is 1/4 of the circle. What about if a student will ask, what about for this integral? Instead of going x go from 0 to 1, x over here go from -1 to 1. So that will correspond to this half circle, okay? X go from -1 to 1. So that's the area of this half circle right here. Okay, next one. This one here, I'm going to help you with the homework online, okay? So we're going to find this by interpreting this in terms of area, okay? So how do you do this, okay? There are two different ways to do this, okay? I'm going to show you the first way, okay? So this is a function. So we have y equal to 1 plus square root of 9 minus x squared. And then you're going to isolate the square root. So you will have this y minus 1 and that's equal to square root of 9 minus x squared. After that, you're going to square both sides, okay? So you have this y minus 1 squared equal to 9 minus x squared. And now after that, you're going to put the x squared and y minus 1 squared together on the same side. So you're going to have this, okay, you're going to have this x squared plus y minus 1 squared equal to, okay, equal to 9, which is the same as, remember this one here, it is r squared, right? R squared equal to 9. So r will be positive 3, okay? And the center for this circle will be 0, comma 1. So I draw the circle here. 0, comma 1 with radius to be 3. So I draw the circle, okay? Remember, this is the standard form of a circle. So this is a circle. But notice that y equal to 1 plus this. So this positive root here will never be negative. So y will always be 1 and above. So y coordinate is always 1 or higher. So that will be this upper half of the circle. Okay, so that will correspond to this upper half of the circle, okay, right here. Okay, now this integral over here, you can interpret this by the area under this curve. Okay, x go from -3 to 0. So will be this a1 plus a2. A1 over here is a quarter of the whole circle. Okay, so that will be 1/4 of this circle, right? Okay, and that circle has radius 3, so that will be the area for the circle is pi times 3 squared. A quarter of that will be 9 pi over 4. Now, what about A2? What about this A2? A2 over here, notice that it is a rectangle. The area for that is the length times width. So the length over here, it is 3. The width here, it is 1. So 3 times 1, so that is going to be 3. So this integral over here will be equal to the sum of these two. So you got this. Now, another way to do it, okay? So this is one way to do it, okay? Another way to do this is to separate this into two parts. So when you integrate this and integrate this, when you integrate the sum of this, then you separate this into two parts. So it's the integral of 1 and then plus the integral of this. Maybe we haven't learned about this. Okay. So for this one over here, the area under this constant function 1 from -3 to 0 is this rectangle, area of this rectangle. So that will be 3 times 1. What about this integral? This integral here corresponds to, remember this y equals square root of 9 minus x squared. It's a circle with center to be, well, if you simplify this, we have x squared plus y squared equal to 3 squared, right? Okay, square both sides and put the x squared and y squared together. You get x squared plus y squared equal to 3 squared. And that will be a circle centered at the origin with radius 3. Okay. This one over here corresponding to the area under this upper half circle. And x here go from -3 to 0. So it will be a quarter of this circle. So which is going to be 1/4 times pi times 3 squared. So altogether, the area under altogether, this integral will be equal to this. So that's another way to do it. You think you guys can do it in the final?
Maybe we need some practice on this.
Yeah, need some practice. Okay, yeah, practice makes perfect. Okay, the next one over here. Okay, let's try to evaluate this integral here by interpreting this in terms of area. Okay, so the function here is y equal to x minus 1. So this is a graph for y equal to x minus 1. Okay, with y-intercept to be -1, slope to be 1. So this is the graph of y equal x minus 1. And then x go from 0 to 3. So 0 here, 3 here. So this integral, you can interpret that as this a1 plus a2. Where a1 is the area here, a2 is this, but it's still negative, okay? So let's find a1 first. What does a1 equal to? It is a triangle. So triangle will be 1/2 base times height. So that will be what? 1/2 times, what's the base?
2.
2. Yeah, you got it. So 2, and then the height is also 2. So a1 here, it is 2. a2 here, it is a rectangle. a2 here, it is a triangle again, okay? But it is negative, below this x-axis, negative. So negative 1/2 times base times height. So that will be negative 1/2. So a1 plus a2 over here will be 2 plus negative 1/2. So that will be negative 1/2. So when you sum these two up, you get 1.5. So that's this integral. This integral equal to 1.5. Okay? Okay. Now the next one over here. This one, we're trying to find this integral by interpret this as the area. So this is a function. Y equal to absolute value of x minus 5. Okay. Well, we know absolute value function is V-shaped, right? And the corner of this is whatever make this inside here to be 0. So the inside here equal to 0 when x equal to 5. So at 5, that's the corner, okay? The change direction here. And then before that will be this, and then this. It's a V shape, okay? Now, this integral, think about that as the area under the curve. So this is the curve, okay? And now x go from 0 to 100. So this integral, think about as this, the green highlighted area. Now, by symmetry, okay, we can just find one of them and you double, right? So what's the area of this triangle?
25 over 2.
Yeah, 25 over 2, right? So it's 1/2 base times height. So 25 over 2. And both of them are 25 over 2. And then when you sum them up, so this integral here is equal to what?
25.
25, right? Yeah, so that's equal to 25. Okay, good. So you found this integral over here by interpreting this as area. Okay?
Question, is integral different than area?
Oh, yeah, integral could be negative, right? Yeah. But then when we talk about area, we usually don't talk about negative area. But right now, when we use integral, because this integral comes from the Riemann sum, so when this is below this x-axis, we have a negative a. And when it's above the x-axis, we have positive. So right now, when you have a positive function, when you have a positive function like this, like the function is always above or touching this x-axis, then that integral, if this is a continuous function, that integral, you can interpret that as the net area under the curve. So you can try to think about it as the net area under the curve. Yeah. So if you are a visual learner, you try to visualize it. You can try to visualize it as the area under the curve. The net area under the curve. Does that answer your question?
Yes, thank you.
Okay. Now we're going to talk about some property of those integral, definite integral. Now, these two integral, you switch the upper and lower limit. So A, B switch places. Okay. Now remember, when you use Riemann sum, delta x is upper limit subtract. Delta x is upper limit subtract lower limit and divide by n, right? We divide it into n subinterval. That's delta x. So, and for this one here, the delta x will be a minus b over n. You see the delta x here? They are opposite. Okay? So therefore, this integral over here and this integral here will be opposite. So, for example, we have this integral. If you switch the upper and lower limit, you put the 0 down and put the 1 up, then you get opposite. So this integral is the opposite of this integral. So when you switch the upper and lower limit, you will get opposite. Okay, so that's the first property. The second property over here, if you integrate this function from a to a, what do you think about the result? What's the result? What do you
0.
think? Yeah, you get 0. Yes, you got 0. Yeah, there's no area right here, right? So it's 0. So in your homework, that's a tricky one. So someone you said, wow, how can I find this integral, right? So what do you think? This integral, the upper and lower limit are the same. What does it equal to?
As from the property is 0.
Yeah, that's going to be 0. Okay, so that's going to be 0. So remember when you do homework, okay, like this. Okay, the next one. When you integrate a constant function, see, this is a constant function, y equals c, okay, from a to b. So think about it as the area under the curve, right, under this constant curve. So what will be the area under this constant curve?
V minus A
Yes, times
C.
times c, you got it, okay? So that will be c times b minus a. Okay, so when you integrate a constant function, it will be equal to this constant times b minus a. Okay, so you can use it as a formula. Okay, for example, when you integrate this constant function 4 from x go from 1 to 6, so that will be equal to 6 times, that will be equal to, so that will be equal to the 4 times 6 minus 1, which is equal to 20. Okay, the next property over here is the sum and difference property of integral. So when you integrate the sum of the two continuous functions, then that will be the sum of the integral of these two functions. So when you integrate the sum, that will be the sum of the, okay, when you find the integral of the sum, that's the sum of the two integrals over here. When you have the integral of the difference, that's the difference of the two integrals over here. Okay, another one is a constant multiple rule. So if you have a constant times this function, this continuous function, and you integrate this from a to b, you can actually bring out this constant in front of the integral. Okay, so you can bring this in front, and you will get c here in front of the integral. So c times this integral. Now let's try this example. Okay, we are given that this integral equal 1/3. We're trying to find the integral over here. First, we use the sum rule for integral. Integral of the sum is the sum of integral. So we got it's the sum of these two integrals over here. The next one over here, for this part right here, this is a constant. 4 is a constant. When you integrate this constant, what does this integral equal to? Everyone? This integral here equal to what?
Or X.
4, you got the 4 part right, okay? 4 times the length of the interval. What's the length of the interval? From 0 to 1, the length of interval will be 1, right? Remember, it's c times b minus a, right? This constant 4 times 1 minus 0. So that will be this 4. Okay, this one here, this 3 is a constant multiple. So bring this 3 in front.
Mm-hmm.
Now, this integral is given to be 1/3, right? That was given. So you have 3 times 1/3 for this part. So adding 4 here, you will have 5. So this integral is equal to 5. Okay? Okay, number 6. This property here. So when you integrate this continuous function from a to c, and then later on from c to b, you can think about it in terms of area, right? So the area from a to c, adding the area from c to b under the curve, that's equal to the area under the curve from a to b, right? So they will sum up to this. Now, for example, in your homework, if we know that the integral from 0 to 10, so we know that it's 17. And we also know the integral from 0 to 8, right here, it is 12. So this one we know, this one we know. We try to find this integral of the function from 8 to 10. So how do we do that? you can use this property, right? So if you know this and you know this, you want to know this. So we use this integral subtractive integral, right? Okay. So we use the integral from 0 to 10, subtract the integral from 0 to 8. So that will give us an integral from 8 to 10. So that was going to be, that's going to equal to 17 minus 12. So that's equal to 5. Okay, the next property. If this is a positive function, when I say positive function means it's non-negative, okay? So when it's greater than or equal to, okay, it could equal to. So if you try to visualize it, it's always above or touching this x-axis. So this one over here, it is the x-axis. So the graph is always above or touching this x-axis. What can we say about the area under the curve? Is it going to be positive? Could that be negative?
No.
Oh.
No, it can never be negative. So it's always greater than or equal to 0. So you can have a positive function that integral is always greater than or equal to 0. Okay. Okay, the next one over here. Okay. If this function f is always above or equal to this function g, okay, on a to b, then what can we say about this integral? Which one is above which one? Then this is always going to be greater than or equal to this. Okay, so the integral of the bigger function is always greater or equal to the integral of the smaller function. Okay, you can try to imagine this picture. Okay, number 9. If this function here is bounded below by capital N and bounded above by capital M, so this is like the floor of this function, and this is the ceiling of this function. Okay, then on a to b, then the integral of this function f from a to b is going to be above or equal to this integral, below or equal to this integral, right? So what does this equal to? Can someone tell me? This is a constant. What does this integral equal to?
N times
10 times
minus a.
b minus a. Yeah, n times b minus a. Is this constant times the length for the integral, which is b minus a? So n times b minus a. This one over here, similarly, it is m times b minus a. So this integral is going to be greater or equal to the lower limit. It's equal to, so this integral is going to be equal, greater than or equal to this lower bound, right? And then times b minus a, less than or equal to this upper bound, okay? Times b minus a, okay? Okay, now let's use this on this example. This is e to the negative x squared. So this is a graph of e to the negative x squared, okay? When x equals 0, this function is going to be 1. When x equal to 1, this function is 1 over e. So it's going to start from x equals 0, y equal to 1. So it starts from here. X equal 1 is 1 over e, end it here. And the function is going to, as x increase, the function is going to decrease. Okay? So the bigger the denominator, the smaller this quotient. So it's going to decrease like this. So this is a graph for this function. So that's the graph for this function. This integral corresponds to this area under this red curve right here, right? So by the property that we just went over, that integral is going to be greater or equal to the lower bound. What's the lower bound? Well, because this is a decreasing function, the y coordinate of this, right? The y coordinate at this point here is the lower bound for this function on this interval, which is going to be 1, right? 1 is 1. And the upper bound, just check, it's not 1. Okay, what is it? 1 over e, right? 1 over e is the lower bound, right? 1 over e. And then the upper bound over here is 1, right? Okay, 1 right here. So this integral here will be greater or equal to 1 over e times 1 minus 1, less than or equal to 1 times 1 minus 0. Okay. So this integral over here is going to be greater or equal to this lower bound, which is 1 over e, times the length of the interval, which is 1 minus 0, and less than or equal to the upper bound, which is 1, times the length of the interval, which is 1 minus 1, which is 1 minus 0. Okay, so okay, which is 1 minus 0. Okay, so this integral is between this one and this one. So that will be an estimate for this integral. I think we are done with this. Yeah, we're done with 5.2. Sorry, I keep you guys a little bit longer today. That's a lot. Practice make perfect. Okay. Okay. So, you guys good? Give me a thumbs up if you guys still here.